Alright, so 33, you work again another long division. So you ask yourself x squared times what gives you x to the fourth, and the answer to that is x squared. Then you multiply, minus 6x cubed plus 9x squared. Now we're going to subtract, so we're going to add the opposite. Okay, so now we have 6 and 3, that's 9x cubed. And then this gives me negative 34x squared, and bring down the negative 39x. So x squared times what gives you 9x cubed? That would be 9x. So you multiply 9x by this polynomial over here. So 9x by this whole polynomial. So 9x cubed minus 54x squared plus 81x. Now we subtract, which is adding the opposite. Okay. So we get, what is it, 20? Negative, what is it, 120? Bring down the 180. So x squared times what gives you 20x squared? Well, that would be 20. And so you get 20x squared minus 120x plus 180. So now we're going to subtract, so we're going to add the opposite. So it's minus plus minus. And when you combine all of your terms, you get 0. Okay, so 34 is asking you to use synthetic division to divide. And so again, I put, you're dividing by x plus 2, so that's why there's a minus. It's a minus 2. And these are all the coefficients of the polynomial in standard form. So we bring down the 3. 3 times negative 2, negative 6. So that gives you negative 12. When you multiply, you get 24. And this gives you 1, negative 2, and you get 6. So this is your remainder. So your answer would be 3x squared minus 12x plus 1 plus 6 over x plus 2. Alright, so 35 is saying if x plus 2 is a factor, find the real zeros. So we're going to test out negative 2x. Well, we test out x plus 2 by doing synthetic division with negative 2. So now I have, bring down the 1. 1 times negative 2, negative 2. Then we get negative 8. Then we get 16 because negative 8 times negative 2. Then this gives me 15. 15 times negative 2 is negative 30. So yes, it is a factor, and this will make up my other factors. So this is x squared minus 8x plus 15. So factors of 15 that add up to negative 8 would be negative 3 and negative 5. So this would be x minus 3 times x minus 5. And then we had the original one, the one they gave you, which was x plus 2. So the zeros are 3, 5, and negative 2. Okay, so this one is a 4 term, and remember I said I always try to factor by grouping, and I organize the grouping in a 2 by 2. And when I try this one, you'll see right away that it's not going to work. But I just want to show you. So greatest common factor on the first row is 4x squared. This is 3 right there. So then 4x squared times what gives you 4x cubed? That would be x. And 4x squared times what gives you negative 20x squared? That would be minus 5. And then x times what gives you 17x? That would be 17. And when you test 17 times negative 5, you definitely do not get negative 4. So this method doesn't work for this problem. So I'm going to have to use the p's and the q's and then try different ones with synthetic division. Okay? Okay, so here we have the list of p's and q's, which are the factors of the constant for p and the factors of the leading coefficient for q. Now I'm going to find the ratios, and to do that, the p over q ratio, this one. This gives me the list of all possible rational zeros. So I start with these numbers and then put them over each of these three numbers here. So plus or minus 1 over 1 is 1. Then plus or minus 1 over 2, that's 1/2. Plus or minus 1/4. Then you move to the next number 2, plus or minus 2. 2 over 2 is already there, so I'm not going to write it again, and 2 over 4 is already there. So then I move on to 4, plus minus 4. 4 over 2 is 2, which is already there, and 4 over 4 is 1, which is already there. So for these 10 numbers, they're the only 10 numbers that are possibly rational zeros for the polynomial. So if you have a graphing calculator, you would plug, you can punch in the equation, and then that way you can reduce the number of p over q's that you have to do synthetic division with. But I'm going to go and do this without a graphing calculator this time. Okay, so I'm just going to try the 1. And it's not going to work. Okay, I'll try the 2. I'll do the fractions, but since I have a few integers, I'll try those first. So see if I get any that work. So bring down the 4, 8, negative 12, negative 24. It's not going to work. Okay, let me try the 4. Bring down the 4. 16, negative 4, negative 16 gives you 1. Oh, it worked. Here's the one that worked. And so what this means, these numbers mean 4x squared minus 4x plus 1. And this actually turns out, this factors as 2x minus 1 squared. And you could do the little box method or the x factor, and you'll see this is what you get. This is also what this one, trinomial, is what we call a perfect square trinomial, where this is a perfect square and this is a perfect square. And if you take the square root of that, which is 2x, and the square root of 1, which is 1, you multiply together and you double. And if that number that when you multiply together and double, you get this number, then you could factor it this way. But if that's too much for you to remember, because you learned this earlier, a couple years ago, but if it's too much, you can just factor it the way we always factor a trinomial, a quadratic. So then you put the other factor, put the other factor here. And so it says find, for 36 it says find all the real zeros, so we're just going to write the zeros, 4 and 1/2. And 1/2 has a multiplicity of 2, so it's a factor twice, or it's a 0 twice. Alright, so here I have another 4-term polynomial, so I'm going to try, I know on the previous problem it didn't work, but let me try it here. 2x third minus 6x squared, 2x minus 6. So the greatest common factor in the first row is 2x squared. Oops. Then this would be x, this would be minus 3, and then this would be 2. Because I'm factoring, first I factored greatest common factor here, and I got this. Then I said this times something gives me this, so that's going to be x. This times something gives me this, so it has to be negative 3. And then this times something gives me 2x, so it has to be 2. Now 2 times negative 3 is negative 6, so that means I factored it correctly. So the factors are x minus 3 times 2x squared plus 2. This is going to give you an imaginary number. So we're not looking for that. They only want the real numbers. So the only real zeros or the only real 0 is 3. So 38, it says find the real zeros of the equation. So they already changed the f of x to 0, and you see it right here. Again, another 4-term polynomial, so I'm going to see if it works here. If it works this way, it saves you a lot of time. So see how quickly we find the factors? So we have that. So the greatest common factor in this row is x squared. So something times x squared is 7x cubed, so that would be 7x. Something times x squared is negative 2x squared, that would be negative 2. And 7x times something is 7x, that would be 1. So the factors are 7x minus 2 times x squared plus 1. So this is not going to, this is not, no real 0 here, but this one will. This one's going to give you a real 0. So the real 0 here, set it equal to 0 and solve for x, you would get 2 over 7. Alright, so 39, they don't give you any zeros to start with. You have to figure them all out by yourself. So I'm going to use p's and q's. So factors of the p values are factors of 40. So that's plus minus 1, plus minus 2, plus minus 4, plus minus 5, plus minus 8, plus minus 10, plus minus 20, and plus minus 40. Okay, q is just plus minus 1. So when you do p over q, it's basically the same list, that this same list right here. Okay, so I'll just kind of draw an arrow to it because it's the same list, so save you a little bit of time in writing it. So we're going to get numbers from that list right there. So I'll start off with 1. Okay, bring down the 1. Oh, it worked. So 1 worked. And so you can try it again, because sometimes you know how some zeros have an even multiplicity, or even odd multiplicity, but great, you know, if there's zeros more than once, they would factor the polynomial more than once. So we'll try the 1 again, because I don't know if it has an even multiplicity or not. So negative 11, 38, negative 40. Remember, we always do the reduced polynomial. Every time you find a 0, you use a new one. So negative 10. No, it doesn't look like it's going to work. 28. Nope. So this one didn't work. So we'll move over to 2. Try the 2. And remember, keep going until you get a quadratic, because at that point you could just factor. This one worked. Good. So I found another 0. So this is x squared minus 9x plus 20, which factors of 20 are negative 4 and negative 5. So the complete factorization is x minus 1, x minus 2, x minus 4, x minus 5. So the zeros are 1, 2, 4, and 5.